Hey math kids, here's some data that we're going to use to find the least squares regression line. So it's based on income, which is measured in thousands of dollars, and then compare that to their grocery bill, which just measured in just dollars. So the first thing the problem asks us to do is to plot this data. And so I have 55 comma 120, so 55, 120 is about there. 36 and 90 is maybe right there. And then we have 25 and 60. We have 47 and 160. And then we have 60 and 190. Then 64 and 250. 42 and 110. And then 50, 150. Okay, we can see that's positive, and they're grouped pretty close, so maybe we'll have a fairly linear outcome. Now, part B says use technology to find the equation of the regression line. Okay, so I'm going to open up my calculator. And if this is your first time doing this, you need to go to Catalog. And then I'm going to hit, I'm just going to scroll down. So we want to do diag on, or diagnostics on. I can't remember exactly what it says. Diagnostic off, diagnostic on. So we do that. If you've already done this on your calculator, you don't need to do it every time. It will stay on. It's just my calculator resets every time. Now, we do that to find the R value. I actually can't remember if on this problem they want the R value, but I always do that anytime I do a regression line because it just helps me to know that. Now we need to make a list. Whoops, but we just hit stat. So just stat, don't hit second stat, just hit stat. Go to edit, and then if there's numbers already in there, you can delete them or just write over them. $50. Okay, now list 2, I'm going to enter the grocery bill numbers. Okay, now what we want to do is we want to go back to stat. This time we want to go to calc. We want to go to linreg, which stands for linear regression line. Hit that. Now we need to tell it where to look. So we're going to say second L1. No, that's L4. Okay, let's try that again. So stat, calc, lin regression. Then we got L1, comma, L2. So it's telling it which list to look in for the x values, comma, y values. Hit enter, and it says y equals ax plus b. And so our slope is 4.18. So y, and then our y-intercept was the b, which is negative 56.7. So we say minus 56.7. Okay, so part B asked us to do that. C says state and interpret the gradient of the regression line. So I kind of already did that. So the gradient or the slope is 4.18. And basically that means that for every $1,000, people tend to spend about $4 more on their grocery bill. So for every $1,000 you make a year, you spend $4 more on your weekly grocery bill. Okay? Part D says estimate the weekly grocery bill for a family with an annual income of $95,000. Okay? So all we need to do is plug in 95,000 to X, or just 95 because it's already measured in thousands. So we're going to do 4.18 times 95 minus 56.7. So we come over here, 4.18 times 95 minus 56.7. And so it's going to be about $340 for that situation. Okay, it says estimate the annual income of a family whose weekly grocery bill is $1,000, or sorry, $100. Okay, so we're just going to take this, set the y equal to 100, and then solve for x. Okay, so we're going to add 56.7. So we get 156.7 is equal to 4.18x. Divide by 4.18. Go to my calculator. So we're going to say 156.7 divided by 4.18. We end up with $37,000 essentially, or $37,500, because it would be 37.5, which translates into 37,500 because it's measured in thousands of dollars. Okay, and then F, comment on whether the estimates in D and E are likely to be reliable. I would say based on our R value, so that's what I would actually look at. Our R value was 0.89. So since our R value was 0.89, and if we go back to page 456 and we look at 0.89, that says we have a strong positive correlation. And so since we have a strong positive correlation, that means that this line is actually a pretty good predictor of future data or stuff that we didn't actually collect. And so I would say that those are both extremely reliable. If you need additional help, please come to Math Lab. Until then, calculator.